All right. So thank you for coming to our session. As I was plugging my laptop into here and getting ready to open up the PowerPoint, it dawned on me that my own laptop and my own desktop, and this was not scripted, I'm the perfect example of what idiotic users do. Okay? This is my desktop. Those are movie files. Literally, it's a movie of my daughter, my wife sent me from her iPhone. I've got icons. I've got other folders with data in them. I've got PDF files, PowerPoint presentations, picture of my father up there in the upper right-hand corner. Just tons of crap and data on my desktop because I like it there. I open my laptop up, the things that I like to see, the things that I like to interact with to give me a good user experience, I put on my laptop. So kind of keep that in mind as we go in and talk about profiles, folder redirection, and how that data should be effectively handled for your users. This is important because this is what your users do. This is what I do. If I didn't do this, I wouldn't be happy using a system that IT would provide me. So with that, let me go ahead and open up the PowerPoint presentation. So, why folder redirection sucks, but is a necessary, and then we didn't have enough space, but necessary evil that we say Shawn has to live with. So if some of you have been to Synergy or read some of the blogs that I've put out on profiles, it's almost a religious debate about what folders should or should not be redirected. Okay? So we've obviously got a few differences of opinion on some of these things. I'm going to give you my viewpoint and my opinion on it, right? And show you ultimately why, in the end, folder redirection does not suck. Yes, it's got challenges, but it's much better than the alternative of not redirecting folders and letting idiotic users copy up tons of data back and forth like I do on my laptop every single time that they log on. So, what are we going to talk about today? We're going to talk about the challenges with profiles. We're going to talk about some best practices for how to handle profiles and folder redirection. We're also going to get into some best practices on how do you design your clusters or your NAS environment to effectively handle profiles and folder redirection, and then ultimately how do you architect it to properly scale it. So if I wanted to support 10, 20, 30, 40, 50,000 users, how would I go about designing my folder redirection infrastructure to do that? And then we're going to close it down with some real-world data. I've ran a lot of tests. I have a lot of numbers from myself, from my lab, from me as a user, also some data from some real-life customers that I support on a regular basis. I'm going to share with you their numbers that they're seeing in their environments with properly configured profiles and folder redirection. So, some assumptions. I hope you know what a profile is, and I hope you know what folder redirection is. If you don't, you're at the wrong conference. So I think it's probably safe to assume that everybody here already knows what a profile is, knows what folder redirection is. So we're going to make that assumption. The second thing we're going to assume is that we're only, I can't stress this enough, we are talking about XenApp sessions, terminal services, RDS, XenApp, whatever you want to call it. We're talking about those sessions and non-persistent pooled VDI. Non-persistent pooled VDI. What this session does not focus on is physical desktops, persistent VDI desktops, desktops that use personal vDisk to provide user persistence, right? Or client-side hypervisors like XenClient, where a user's got a locally running VM. In those instances, right, the best practices and recommendations for folder redirection really do not apply. And I think therein actually lies a lot of times some of the differences that we have about whether or not certain folders should be redirected or not. Because if you have a persistent desktop, then you should not be redirecting the app data folder, right? There's no need to do that. But when we're talking about XenApp, or we're talking about non-persistent pooled desktops, what is our challenge? That is a blank slate. Every single time the user logs on to a non-persistent pooled desktop, or every time they access any XenApp session, hopefully if you've configured it correctly, it's a blank slate. They have no profile. They have no data. There's nothing there, right? So what does that mean? If I just simply let them log into a blank slate every single time, and I don't let data persist, we all know what happens. I got to set up my Outlook profile again. I lose my Outlook signature. There goes my custom dictionary. I got to add netscaler back as an acceptable word to word every time I do a spell check. You know, really stupid, annoying crap happens. I lose my cookies. You might think, oh, big deal, you lose your cookies. It is a big deal because every time I log into my Chase Visa card, if they don't see the cookie, they got to send me a text message I got to respond to. Well, that sucks. I don't want to do that. So my cookie better persist between my Internet Explorer sessions so I don't have to have Chase send me a new text message so I can look at my credit card statement. And there's myriads of other third-party application settings, right, that would be lost if we didn't persist the profile. So what do? Well, for years, eons, we've had roaming profiles. How many people have roaming profiles in their environment or have done them, right? Almost everybody. But what does that mean? What's the challenge? Well, what does a roaming profile do to a logon time? What's the longest logon time you've seen out there due to a roaming profile? Anybody, shout one out. 10 minutes, 35. Wow, that's probably a winner right there. I have seen 20 minutes. I kid you not. I've seen 20-minute logons at customer environments with roaming profiles. I actually have a customer that I support, and they do roaming profiles on their fat physical Windows XP desktops. So forget VDI. They've been doing roaming profiles for the last 10 years on their desktops. And they've got offices in a lot of different places. And it's not uncommon that my logon, when I go there to support that customer and I log in with my user account, it's anywhere between 3 to 7 minutes, right? Because I'm pulling data over the WAN, and they have a fast WAN link. So roaming profiles, you know, I log on, I get up, I walk away, I go do something, right? And then I come back. And that's not very secure because when I come back, my desktop's unlocked, right? So roaming profiles, yeah, they give my personal data, but they add a lot of time to the logon process. So we know that that's crap. But what else is that doing? If you ever really look in there while that user's sitting there waiting, you're also destroying your infrastructure. You're putting a massive load on your file server, and you're putting a massive load on your network. So you're not only causing the user to wait, you're causing your infrastructure to get stressed out as well. So it's that storage and networking impact, right? That stress that gets put onto our storage and networking systems that really give us the grief when we're talking about roaming profiles and how do we get that data back to a non-persistent desktop. So we know that the profiles are going to be ginormous, right? We know that we have to do a roaming profile or like a solution like Citrix User Profile Management, right, in order to slim that logon process down and deal with it. The other thing that almost everybody agrees with is that at a minimum the documents folder, right, the user's documents should be redirected to the home directory. How many people at least do that for redirection, right? Right, it's a no-brainer. Why would I let the documents copy up and down every single time the user logs on? So we redirect that to the user's home directory. We agree that that redirection makes sense. A lot of people also agree that the new downloads folder in Windows 7, that should probably be redirected too, right? I mean, why should I let the user be downloading tons of data and then I just copy it up and down every single time? So the downloads folder, because it's a data folder, yeah, we redirect that. And then what about the desktop folder? Well, if I'm the user, you damn well better redirect my desktop folder, otherwise I'm going to be putting a major stress on your network, right? So in the end, I find that, how many people here usually redirect desktop? Okay, most people capitulate to that because users do what I do. They use the desktop as a data folder. So we've already acknowledged that, you know what, it's kind of dumb to copy folders up and down, log on, log off. It's a really dumb thing to do, so we should be redirecting folders. So we redirect desktop, we redirect downloads, we redirect my documents, of course, and we all agree with that. So what does that leave us with? Well, that leaves us with still a lot of folders. App data, right, the highly contentious folder that we'll have discussions here about whether we should redirect or not. Hey, you got the contacts, searches, start menu. There's a ton of shell folders out there. You also have a myriad of third-party applications, right? Citrix puts a folder in the root of user profile. Why do our developers do that and they don't, not even all of our developers can use the %appdata% variable. So we'll put a folder in the root of the user profile. Java will put a folder in the root. So there's tons of third-party apps. And those aren't shell folders. I can't redirect those, right? Because they're not part of the basic operating system. It's the developer's writing %user profile %, putting his data out there. So what's in there? Do we need it? Do we need all that extra crap? Can we just get away with the NT user DAT, the registry, and the data folders being redirected? And the reality is, we really can't, because that other data that's in there, there's gold in there, as far as the users are concerned and as far as their user experience is concerned. There's things that you need, right? We know there's things that we need to keep in that profile. So it's a battle between what do I take and what do I don't. So what do? This is what we end up doing. We end up collecting a big pile of crap because there's a few pieces of gold nuggets stuck in the turd somewhere. So we say, oh, we'll just capture all the crap and deal with it. I know, yeah, I know. And that's what we do. And if we're not redirecting our folders and we're just letting things roam, you're catching a lot of crap with the gold. So, what are the typical size? You know, once we've redirected desktop documents downloads, can we all agree with that? How big are those other folders that end up roaming by default? Well, every environment's different. And you'll see numbers, I'm sure in your own environments, you see users with very small profiles, you see users with huge profiles. And all the research I've kind of done and looking at customer environments, every time I go to a customer, I like to go into their profile and directory and just spot check. Like, how big are these things? What's the average size? And what I've found is that for very task-based workers, people that just run a few Office apps, maybe SAP, but don't do a whole lot of other stuff, they're not power users, they're not computer savvy, they're not saving their own backgrounds and even changing those things. They're just task workers. It's rare to see the profile be less than 100 megabytes. I mean, it's just going to grow to at least 100 megabytes. And that doesn't include app data local and temp and all that stuff. That's just the regular roaming profile junk. Now, for your standard Office user, your typical run-of-the-mill user, after about a year, okay, because the profile starts out small and slowly it grows and grows and grows, it's not uncommon to have an average profile end up being about 500 megabytes that sits inside that directory. And for your power users, you can easily push beyond 2 gigabytes. On my laptop, my profile is 3 gigabytes, right? And that does not include my local app data, right? That adds another 4 gigabytes. And that does not include my desktop, my documents, because I redirect those, right, to actually another disk on my computer. But just my profile data, 3 to 7 gigabytes, depending on whether you collect app data or not. So, and we can see that be even larger. However, at 100 megabytes, I would argue that's too big to just simply say, even if it was the smallest 100 megabyte, I'm going to download it and upload it, log on, log off every single time. That's still too big, and that's really probably smaller than the average. That's about the smallest task worker you're going to get. So what does this do? What does it look like? Most enterprise customers, right, they might have multiple SANs. A lot of our, departmental customers or small and medium businesses especially, you don't often sometimes see more than one SAN. So what does that mean? Where's the XenApp LUN and the VDI LUN? It's on the same SAN as the LUN hosting the profiles. Whether it's a file server front-ending that LUN, or whether it's NetApp front-ending it as a CIFS volume, right? It's on the same frickin' SAN a lot of times, right? Different RAID group, yeah. So different LUN, different RAID group, but it's on that SAN. The data's there. It's sitting in the SAN cabinet. So let's just take a typical use case with a 300 megabyte profile. What happens? The user downloads 300 megabytes from the SAN, from LUN 1, into their virtual machine, and pulls that over the network, while simultaneously over a separate storage network, pumps it right back up to the SAN. So we're just copying from one LUN to another using a virtual machine as our conduit. And then when they're done, they take anything they changed and they zip it right back up from the other LUN. Does that just seem freaking unbelievable to anybody else? If you were to architect a system that did that, right, present that to a scientific board, would they look at you and go, that's the most idiotic thing I think I've ever seen. Why are you doing that, right? But that's what we're doing. That's what we're doing with our roaming profiles. So, how do we fix that? Really? Simple. It's folder redirection. That solves about 80% of our issues. It's been around forever. Microsoft has made it better with each iteration of their operating system. And with Vista and Windows 7 and later, they've added a lot more shell folder options for redirection. They put them there for a reason, so that we stop shoveling crap from one LUN to another, right? And just go access the data when you need it, leave it sit where it originally located, manipulate it there if you have to, and when you're done, you leave it there. Because that's how we should manipulate files when we work on them. So, and that includes app data roaming, and we'll get into that in a little bit. But we got to redirect all those. However, that doesn't fix everything, right? There's still other challenges that we got to deal with, because not everything sits inside of a nice app data folder or a nice shell folder created by Microsoft, right? You have third-party applications. Citrix, guilty. Sun, guilty. I mean, you look in the root of your user's profile, you'll see a bunch of your different third-party apps. Shame on them, right? That's just poor coding on the part of a developer. So this is where roaming profiles and folder redirection end up sucking, right? Because they don't fix that problem by default. So we need to fix that problem. And how do we do it? We use a managed profile. Citrix User Profile Management, we give it away for no cost with every XenApp and VDI instance that you buy. I would argue that for pooled non-persistent desktops and XenApp, it's the best solution out there. It's free. You already bought it. We've designed it specifically for that. We actually bought it from a company called Sapago. Who remembers Sapago or still might even use some of their stuff, right? We went out and we acquired a third-party profile solution. You know, you have AppSense, you got Res, you have some others. And they do some other neat things that go beyond XenApp and virtual desktops. But for XenApp and virtual desktops, this solution does probably more than what you need. And we've extended it quite a bit. We've added a lot of features to it for those two specific use cases to make it an effective tool. So it really can fix a lot of those problems. The thing I like the most about User Profile Manager is it really is just a roaming profile. It's simply using really the same kind of fundamental engine that roaming profiles use. We just add a few features to fix the deficiencies of roaming profiles. So we said, what works with a roaming profile and folder redirection? What doesn't? All we do is fix the things that don't work. So from an architectural perspective, it works logically like a roaming profile. How do we configure it? Group policy. No management console, no separate console. It's a group policy. We give you an ADM template. How do you store the data? On a CIF share. The exact same way you would create a CIF share for your roaming profile. So it really is a roaming profile with just a few GPO enhancements to fix the deficiencies of roaming profiles. So I'm going to focus on that as the solution to fix these issues where folder redirection ends up falling down. We've got 3 key features in User Profile Manager that specifically address the deficiencies of roaming profiles and folder redirection. Those features are profile streaming, directory synchronization with a powerful inclusion and exclusion rule engine, which is the key, as well as a feature called active writeback. So if you properly tweak these features, right, you're going to solve for pooled non-persistent VDI, and for XenApp, you'll solve 99.99% of your profile issues if you properly use these. You'll make most of your issues go away. So let's talk about a few best practices with folder redirection and with user profile management in particular. First, I'm just going to go over some highlights. I wrote a 3-part blog series on using UPM with folder redirection. Has anybody read it? Anybody? Okay, a few of you have seen it. So I encourage it. It's really more like a white paper as opposed to a blog. I don't write white papers anymore. It's just easier to write a blog and put it up and call it a day. It's easier to find, easier to Google, easier to search. So it's really more of a white paper. That blog covers everything. Everything we're going over inside this session and more is in there. So I encourage you to check it out, encourage you to read it, but we'll give you a few of the highlights. So first best practice, redirect all the folders. The default folders that Microsoft provides, what they put there inside their native group policy engine, right, we're going to use it. We're going to use the tool Microsoft gave us. We're going to use folder redirection. Okay? The other key thing, make sure that the CIFS or NAS infrastructure that you're redirecting to is actually in the same data center as the XenApp and non-persistent VDI. It's a no-brainer, right? Let's not copy this data over the WAN. It kind of defeats the purpose. So all the folders you redirect, pick a CIFS location in the same data center. Now, there is one exception, because every single one of your environments is unique. And some of you actually might have an exception to that rule, right? The documents folder, the home directory. There are instances where users going to hit a VDI desktop, say in DC. So I redirect all their folders to DC. Their home directory is in DC. Their documents get redirected to DC. But occasionally that user consumes a XenApp session in Colorado, or hits a VDI session in Colorado just to occasionally collaborate and work on some other data sets in a desktop in Colorado. But they're primarily in DC. Do I want to let them have their home directory and redirect their documents back to DC when they're in Colorado? I might. My WAN might be robust enough. They might not really be doing a lot of work when they're in Colorado with their home directory, but it's kind of nice to have it there. So that's okay, right? Every situation is unique. You evaluate your situation, you decide what's the best solution. You might decide that for the XenApp apps in Colorado, the DC users never need their home directory. So let's use a group policy and give them a terminal server home directory in Colorado so that they map their home directory to a different share that's local to Colorado. You might decide that's the best solution. That's perfectly acceptable. So analyze your own environment, make the best decision for your users. So, but that would be the one exception. But for app data, for everything else, pick a location that's local. So the inclusion and exclusion rules are really the key to making this successful. All right. First thing that I see missed a lot is if you redirect it, you should exclude it. All right. You think, well, if it's redirected, why don't I need to exclude it? It shouldn't be there anyway. It shouldn't, except stupid application developers, Citrix included, write things to %userprofile %/ instead of querying the shell folder location. How many times have you redirected app data or folder like that, and then you go back to the user profile and you're like, why is there a C users Dan app data roaming folder here with crappy app and a bunch of crap in it? Because the developer, when he decided, you know what, it's a best practice to save things to the app data folder, so that's what I'm going to do. I'm going to follow best practices. I will put stuff to the user's app data folder. How do I find that? Oh, it's %userprofile % / app data. Instead of reading the shell folder from the registry, or instead of using %app data %, right, which would go to the redirected location. So it's an idiotic programmer that made a mistake, okay? So if you redirect it, exclude it. That way it's gone. It's better to let that data disappear. Now you might say, well, wait a second. If I just exclude it, and yeah, the crappy app wrote the wrong path, then the user might lose app configuration settings. You're right, good. Because if you put your head in the sand and pretend you don't have any crappy apps that need to be remediated, right, you're just being ignorant, right? You need to know that you have a crappy app. So you do that. User says, you know what, I lose all my menu settings every time I open my app. Okay, let's take a look. Well, hey, there we go. Your app's writing, instead of to app data, it's writing to %userprofile % app data, crappy app, whatever. You want to know that so that you can fix that. And there's two ways you fix it. First, you find out what the app is, and you figure out, can I get the vendor to change it? I can't count how many times, even publicly traded companies, I've gone to, opened a ticket, got the customer on my behalf to go and say, you guys were stupid with your code here. Why didn't you use %app data %? And guess what? They fix it. Somebody's just got to escalate it to tell a developer you screwed up. I also have customers that develop their own house applications that do this all the time. So I go back to the developer. I said, well, we wrote that app in-house. Great. Who wrote it? This guy. Take me to his cube. I want to have a discussion with him. Right? And when you show them what they did wrong, they're usually like, oh, crap, yeah, you're right. You know? Next iteration, they fix it. So let's find the crappy apps so that we can clean up the crap. Now, you can't always get the code to change, right? So this is where our inclusion rules come into play. I've excluded app data. Okay, you wrote to %userprofile % crappy app, you know, whatever. I will then look at that application and say, what are you writing there? Because if you were dumb enough to make that mistake, you're probably dumb enough to use the app data folder as a temp folder as well. and you're probably writing a lot of things that don't need to persist. And I'm not going to grab it all. So you look at it, you can usually look at the files very quickly and be like, oh, there's some INI files. Yeah, they're going to have user settings in them. And then you see a bunch of other crap that's in there, and you're like, that's just temporary data. It's garbage. All the user needs from that application is the INI file. So I've excluded it by default. Now I add an inclusion rule for, crappy app /config start at INI. Problem solved. Now instead of roaming the entire crappy app folder, I am synchronizing up and down just the file or files that I need. Much more efficient. Yes, this takes work, right? We could just put our heads in the sand and pretend those apps aren't out there and leave and, well, hopefully everything works okay. Or we can actually take the time to try and tune the system to the best possible ability. And it takes time. It takes effort to identify those faulty applications. But if you do that, now you've remediated the application. You've potentially given the developer a new best practice so that he can fix it. And in the meantime, you've come up with a solution to save that app's data without taking the whole pile of crap with it. So we also have a feature called active writeback. The active writeback feature, or actually let's talk about profile streaming before we talk about active writeback. So we talked about inclusion and exclusion. Profile streaming, which is actually a very good feature, okay, allows us to, instead of downloading every single file that's in that roaming profile directory, instead of pulling them all down, we say, okay, let's create stub files representing them on the user's operating system, basically little pointers. And if perhaps the user or the app touches the file, then we'll go to the file server and we'll fetch it down. That's great. That's much more efficient than saying, I'll take it all no matter what. Now you're at least saying, I'll only copy it if the user actually invokes it and needs it. So it's a great feature to use, but it's not a crutch, right? It's not a reason to say, well, I don't got to worry about inclusion and exclusion, right? Because you still might be pulling crap down you don't need. And that's where the inclusion and the exclusion is going to help you fix that. You have to be careful. Some virus protection applications don't like that kind of architecture where you've got stub files that the sizes don't match up. Your enterprise virus, the latest versions, if you're on 8.7 and later of McAfee, if you're on a later version of Symantec, they actually work okay with it, so you're okay. But if you're using some smaller sort of third-party or more Soho type virus protection, then you got to be careful with profile streaming because those virus protection engines get a little upset sometimes when file sizes aren't reported correctly and they want to try and scan the file and the file's not there, and it can cause issues. Active writeback, our third feature, this is one that I should put a big asterisk around because it can be good. Because what happens when a user logs off? All that data we did work with, that what was downloaded or roamed with the profile, it's got to get copied back up at logoff. So we push it all back up to the file server. That happens at logoff. Active writeback says, well, instead of waiting to log off, if you change a file, why don't I just copy it back to the file server mid-session? So when you log off, a lot of your data might already be up there. If you've got also issues with sessions not disconnecting and logging out cleanly and things like that, that can help save data, right? Because the user didn't log off. If they didn't log off properly, well, then their profile never got uploaded. They might have lost some of those changes that they created. So active writeback would fix that, right? Because it may have already uploaded it for them. It can put a pretty significant load on your network and servers, though. And think about it this way. Imagine I copy a 10 megabyte file down from my profile. Okay, I had to roam it or synchronize it. Nothing I could do because it was written to the root of the profile. I included it. It's 10 megs, it comes down. I modify it. I modify one block of data out of 10 meg. Well, the whole file changed. We're not a byte level or block level differencing engine. Active writeback 5 minutes later says, well, you did change that 10 meg file. Let's copy that back up to the file server. Then 10 minutes later, you change it again, another block. And 10 minutes later, it gets copied again, and it gets copied again, right? And the user's on their session all day long, and now they've copied that 10 meg file back to the file server 10 times. And then, so you have to be very careful with using that feature. I'm not afraid to turn profile streaming on by default. I would not turn active file writeback on by default. With all that being said, if in the end, after you've redirected everything, you're less than 50 megabytes of profile size, then those features aren't doing a whole lot anyway because you've already probably optimized it, right? But if your profiles end up being a little bigger, definitely, especially profile streaming, going to add a lot of value. I'm going to go through a few redirection myths that are out there. Talk a little bit about them now, and towards the end of the presentation, I've actually got some cold hard facts of real world data that will disprove some of these myths. So some of the myths that are out there, that redirection slows things down. It's going to make everything run slower. Well, that's just wrong if you've designed it correctly. Yeah, if you have an overloaded file server, if you didn't carve out enough IOPS on the LUN for the file server, right? If you redirect it over the WAN, then yes, it might slow things down. But if you do it properly, it doesn't slow things down at all. Redirection gives you a single point of failure because now I got to rely on file services and NAS services, network services to get my data for the user. This really is sort of correct and wrong. These are non-persistent desktops. These are XenApp sessions. There's no data there to begin with. If the NAS or file server, or if it's AppSense and it's all sitting inside of a SQL database, if that one location goes down, users lose their data, right? Because there is no locally cached copy, you don't have to worry about that as a problem. Now, if you had a persistent desktop, then that would be true, right? If you had a persistent desktop, then, and you redirected app data, and the file server went down, persistent desktop would lose its app data. So don't do that with persistent desktops. Let app data stay on that persistent store. But for non-persistent desktops, you make your file servers highly available. If they go down, well, user would have been down anyway. Redirection will break most of your apps. Again, this is complete bullcrap. I've been redirecting, I have literally millions of seats of XenApp and VDI where I've redirected app data, right? And I could probably count on two hands and maybe 1 foot the number of apps that have really been like, God, this is a bear, and this app does have some serious problems, okay? They're out there. There are apps that have problems redirecting app data to a CIFS location, okay? 95% of the apps work by default, okay? They just work. And each year, that list gets smaller and smaller and smaller because the developers are becoming more aware of shell folders and app data folder locations and the fact that they could sit on a file server. So that list of applications that has issues shrinks every year. And what I would argue is, if we know that 95% or 90% of the apps you install work fine with app data redirection, why would you throw the whole thing out when it's working fine for 90% or 95% of your apps? Would it not make more sense to say, the 5% of the apps that don't work, let me figure out if I can remediate them, right? And if you look in the blog, I give you a bunch of examples of how to do that. Through scripting, through application virtualization, whether it was Citrix app streaming, app Ving the app. There are a lot of tools, putting the app on the Zen app server, installing it locally, not redirecting on that particular Zen app silo. There's a million different ways to go about remediating that application. So remediate it first before you decide to throw away the whole folder redirection architecture because you found one app that had an issue. So with that, I'm going to hand over to Nick. Nick's going to go over some file server and NAS best practices and also talk about how you can go about scaling folder redirection and profiles.
Question? Yeah, before we get started.
How about implementing block level change for the active write-back?
Implementing
Block level change?
It would be great. Differential updates, block level updates is a very difficult thing to do. I mean, think about DFSR.
Which we'll talk about in a second.
Right. Which is a theoretical block level differencing engine. It's expensive from a resource perspective, overhead perspective. It's just really not feasible.
And
think about things like Dropbox, ShareFile. Do they use block level differencing? No, right? And if they could, they would save themselves a lot of network bandwidth. It's hard to do.
And we're not the right ones to tackle that problem, right? We're little old Citrix with little UPM.
Block level differences? When did they? What's that?
You can try it with BMPK.
When did they start doing that?
A long time. Yeah, you can see it indexing the files when it comes up. That's why it indexes them first. And you'll see
Great, that's awesome. I use Dropbox for my personal data at home, so that's good to know.
guess Dropbox.
He says Dropbox
start
does
doing
do
it.
a block level difference. I don't think that they did when they first started, though.
I don't think so either.
No.
Yeah.
Just real quick, does the UPM tool, does it assume that you're only doing VDI and that, or
You can use UPM for physical desktops. You can use it for whatever you want, right? I would argue before you start just rolling out profile solutions for those other desktop solutions, there are different best practices for handling profiles for those types of environments. But absolutely, you can use UPM. It's not written just for XenApp or Opera System VDI. It can be used as a profile solution on anything. If you have a mix, you could mix it, absolutely. For the Microsoft shell folders, I doubt it. I mean, we had that XenApp special folder redirection, right, where we could redirect your documents to like whack whack client dollar. So we do have some stuff with XenApp today. I don't think there's a big push to look to extend that any more than what it is right now. Dealing with shell folders gets messy, right? Especially when shell folders expect to be local. So anytime we start talking about cloud and separating the location of your desktop and from a certain shell folder, then we talk about pulling data over the WAN and things get real messy.
Which is my first point there, good segue. Yeah. But before we get started, I just want to say that I love BriForum. I mean, we can say crap.
Yes.
We can show elephants taking craps. We can wear whatever we want. Dan's got his AC/DC shirt on. It's always nice to be here. And before maybe we get started with this stuff, quick poll of, so who does redirect app data? Okay, so maybe about 50.
20%?
40%. Yeah. And then who redirects all shell folders? Very few. Yeah, so I mean, Citrix and Microsoft were both sort of guilty. The user profile, or Metaframe Presentation Server user profile best practices. You guys ever read that tech note? It's our #1 most visited article ever on support.citrix.com. So hopefully you've read it. But basically what it says in there is you should redirect my docs and app data. Those two. That's what it said for 10 years. And that used to be sort of the best practice, right? And then Microsoft sort of made it worse because they only exposed the initial 4 shell folders. Yep. So those 2 plus start menu desktop, right? They just exposed those in the GUI. But if you were smart enough, and Dan and I wrote an ADM file like 10 years ago that basically it just did the other things in reg keys, and we put it in ADM files. It's a custom ADM we used everywhere.
Folderreader.adm.
Exactly. So yeah, okay, that's interesting. All right, so yeah, let's get started on the file server NAS best practices. So the first one, as Dan said, I mean, it sounds stupid, but this is timely. So last night I was up at midnight, and I support about 5 projects a week on the West Coast, and one of our project teams on site for this really big client that makes tax software that will remain nameless. And they wanted to put their CIF shares in one location and then have all the infrastructure and app VDI stuff in their primary data center, located across a 50 millisecond WAN link. I mean, seriously, last night I ran into this. So this sounds stupid, but I have to say it. So yeah. And then 10 gig, obviously, if we can, same core switch if we can, that's great. If you're in a 1 gig networking environment, use bonding, LACP, do all those things. We still see a lack of that out there from time to time. If you're using highly available configurations, so if you're using Microsoft stuff and you don't have maybe a higher end NAS or SAN, failover clustering's there. It's good, it works. NetApp has their clustered data on tap now, so multiple nodes, EMC. They have a slew of NASs, and they have a bunch of different data movers and heads and controllers. So just make sure that you use a highly available config. Yeah, don't be that guy that uses the single Windows file server, and we still see it. We still run into it. It's unreal. If you're using, and this one gets you, I think gets a lot of people still. So we still have a lot of XP clients. We still have a lot of 2003 32-bit environments, right? XenApp 4.5, 5.0, whatever we want to call it. You know it, you love it, so do we. It's still out there, even though it's end of life, end of support, or whatever, it doesn't matter. But even if your file servers, this is kind of a common myth too, even if your file servers are 2008 R2, it's like, nope, they're 2012. We're good to go. We're using SMB2, 2.1. You're probably not. Because a lot of times you need to tune those XenApp servers, which are your SMB clients, to negotiate with your file servers that might be ready to go using SMB 2.1 or 3.0, but you need to tune those clients because SMB, the way it works, SIFs, it negotiates on the lowest common denominator, right? So we've had these slew of reg keys that we've been spouting off for the last decade, I swear. And we still run into this. I just want to show you the article. So Dan wrote a pretty good article here, just a screenshot of it if you want to Google it. But it has all those reg keys we're talking about. And I think he even did a Wireshark trace in this. Yep. You'll see SIFs and SMB negotiated on 1.0. Yeah, and just like I said, most NASs they'll support it, of course, these days. But sometimes if you have an older NAS or it has firmware that's a little bit older, you probably need to upgrade it or flash it to just make sure you can take advantage of SMB 2.1. So DFS, and there's two parts of DFS, right? There's namespaces and there's replication. So DFSN, we'll talk about first. That's your friend. DFSR, maybe not so much your friend, but we'll talk about why, at least in this context. So namespaces are good. They should always be used. Most NASs, like of course Windows supports it, right? But most NASs also. So if you're using NetApp, sys filers, yep, works with that. Even those guys over at EMC, it works just fine. We do it all the time. Don't hard code server names. Unfamiliar with sort of how that is or how that works. It's just one logical, name for it, and you can have 4 file servers underneath it, right? Just a simple DFS namespace you create. It's just dead simple. DFSR, so we say don't use it. So again, we're talking in the context of profiles and redirected folders, user data. This is where it gets really hairy. And I've seen customers actually try to do this, to use read-write replicas, and have both active targets with DFS replication, and it just falls down, and you get the dreaded profile corruption, and you have stale copies of redirected folders over here and over there, and nothing ever matches up. So DFSR, it's great, I think. It's a nice little tool, right? It's a Windows tool, another freebie tool. Good for the smaller environments, maybe that mid-market, probably not, not suitable for the enterprise space, which is nice because, again, most of the customers we work with in the enterprise space, they have some sort of NAS or SAN, appliance at their disposal. And these guys are the ones that are good at what they do, right? These are the guys that make these mirror view, snap view, snap copy, all these fancy tools that cost $1 million and do block level replication. So I wanted to throw up this screenshot. It's like, what can go wrong with DFS replication? Or does Microsoft support active profiles and with DFSR? No, they don't. And it's gotten so hairy that they had to write this whole separate article that has like all the different scenarios. I mean, you've probably seen it. It's like Microsoft support stance on DFS replication, like active, blah, blah, blah. And it's like a tech note or an article, and it's like 40 pages. I mean, it could be a white paper on all the crazy stuff that can go wrong. So this just kind of shows you what can go wrong. But yeah, I got the URL in the slide notes if you're not familiar with that one. But bad things can happen. All right, so now let's talk about, so we covered the basics, kind of DFS namespaces. Let's talk about how we scale UPM to an environment with 50K users, which we've done in the field. So yep, we say it can easily scale. How do we do it though? So let's first talk about what UPM is comprised of and how it works, right? Dan kind of hinted at it earlier, but it's group policy and it's like shift shares. It's stuff that's been around, we use every day, it's easy, it scales, it works. But there are a couple little tweaks we need, and a couple little tricks we need to do to make this work. So yeah, if you're not familiar, UPM, we don't have a console. God knows we don't need another console at Citrix. We got enough of those, even though we said we're down to one console, I think now. You all know. So yeah, you configure with an ADM. An Active Directory group policies scale well, right? We have customers, Active Directory Force, that have 500,000 objects, 1,000 GPOs. So adding one more GPO and a couple OUs is not going to be a big deal for us here. As far as user data, again, it's going to go on a CIF share at the end of the day. And that could be backed by a NetApp, a CIF file, or whatever. But that's pretty easily too. And I did clarify, properly configured CIF scales well. Right. If you're using SMB1 or you don't do any tuning or don't have the IOPS to support it, yeah, it's probably not going to work that well. It's probably not going to scale to 50,000 users, let alone 10 or 5. And then here's kind of the trickier part. So we talked about group policy, so group membership, and then there's variables. And that's kind of the trick, I guess, to make it work with UPM. So let's just take the assumption that a single file cluster that's tuned properly or high-end NAS, let's say a NetApp or something, can support 10K users. Let's just make that assumption. We want to scale this to 50,000 users. So we basically need 5 of those units, right? These CIFS units, we'll call them. And that's where you don't just want to put everybody on one single target, right? So we probably want to distribute the load, evenly and intelligently. And there's 2 ways to do this. I mean, you could create, multiple different desktop groups in like the Zen Desktop Studio and have like 10K, 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 10K. You could have like 5 OUs and have a different group policy with a different, URL obviously to apply to every one of those OUs. But you don't want to do that for, the first reason you don't want to create the separate desktop groups and catalogs is because, if a user's like, home to that first 10K group, if it goes down or offline for that host or something, they can't get to the second 10K block, which is stupid. So we don't want to do that. We want one nice kind of big container. And the second reason, we don't need to create the unnecessary 4 or 5 OUs if we can do it with one and get creative. So we use variables and AD attributes actually to do this. All right, so yeah, again, the full details are covered actually in part 2, I think, of Dan's blog. So check it out, but I'm going to run through it really quick. So all CIFS units are going to share that same DFS namespace, so abc.corp/New York, right? That's the namespace. And we might have 5 different New York filers, and NY12345, let's say. And each CIFS unit is just a subfolder or a leaf node, a leaf target, basically, in DFS. And then the first thing is we got to basically home, each of the users to one of those 5 different CIFS units. So New York 1 to New York 5, we have 5 AD groups, and that's important for setting folder redirection. So by the way, folder redirection is set in a user policy, right, within group policy. Why can't we? So why do we have to use an AD attribute? Why can't we use something else? Or why do we have to use an AD attribute? Anybody know why? It's not really specific to UPM. So UPM can't read user environment variables. But anybody, and the same reason like why you have to set a terminal server, the roaming profile or mandatory profile path, it's a machine or computer policy, right? So Microsoft screwed us from the beginning. So, and UPM basically can't read that since it's a machine setting, not a user setting like folder redirection. So basically what we have to do is use an Active Directory attribute and sort of insert it in there, and that'll basically identify who's who and what different CIFS unit they land on. And then basically the path ends up looking like this. So there's the part 2 where you can kind of find more details. As far as the AD attribute, so this is basically what the path ends up looking like. And you'll see there we used a random thing like UID, and there's, if you actually pop open, Active Directory, you can see all the different attributes inside of there. And there's a million.
There's a ton that are unused that you can pick. I don't think too many organizations fill out the international IDSN number on the user's attribute in AD.
I mean, I was just looking actually this morning about, there's just tons. It's crazy. Yeah. So yeah, and so basically what you got to do is you have to write a script to basically populate that attribute in Active Directory and basically home those users. So you basically give them a little NY1 or NY5 in their Active Directory attribute. And then basically when we read this is the central store path for UPM, it's basically going to parse it. So that little pound, that's, in whatever UID there we have in pound, that basically denotes the UPM that, oh crap, so go look at AD attribute and basically insert that there. And then there's the normal stuff, username, user domain. As far as folder direction, so how do we do that part? So most people probably just configure, you go to this tab, right, this is app data, and you can use the basic one, right? That's what probably everyone does for the most part, and it's just a single location. Well, there's an advanced, if you drop that down, and you can basically specify the different target for different groups. And that little group we created earlier, the NYC NAS1 or whatever, that's basically what we're going to use there. So it's pretty straightforward. There's 4 there. There should be 5 in my example, but yeah, you get the point. Any questions on that?
And I think the important thing to remember there is this is if you need to scale to a very large environment, right? We're talking, you're going beyond 10,000 users. If you're only going to have at most 10,000 named accounts or potentially 10,000 desktops that are run, if you buy the real high-end NAS units that are out there, a lot of times you can actually get 10,000 users on a high-end NetApp on CIFS volumes. It is possible. Some people still like to carve it up even smaller, but we're talking, you got a couple thousand users, one path is probably going to be fine. You don't have to worry about it. But you're dealing with a big enterprise, you want anybody to be able to log into any desktop, and this is the architecture that we go with that allows us to do that.
Before I hand it back over to Dan, anything yet? Shawn, nothing? We're good? Everything's gravy?
I'm being polite.
He's hiding out back there. All right. So I'm gonna pass it back over to Dan. He's gonna run through some of the real world numbers and stuff.
So I did a lot of testing I used myself as a real user. In fact, for one of my tests, I took all my profile, my folder redirection, and had a file server in my home lab, and I said, let me move everything onto a file server as I'm working here from home, and actually consume as a user folder redirection and a profile coming up and down, and see what kind of results I get from a user experience perspective, as well as you know, the results that I'm going to get on the file server for what kind of IOPS load and network load do I generate. I also just did some other basic lab testing with some like login VSI workloads and some other kind of automated scripting routines, building workflows that do a bunch of different stuff. I'm going to go over those results. And then more importantly, I did a real world customer. So I have tons of customers that I'm doing non-persistent VDI where we're doing everything as we laid out here in the presentation so far. So I actually ran perfmon on their servers and on their file server volumes and on their NAS units, and said, let me get the data, the real data that these users are actually generating as a load perspective. And I'm going to share that data with you too. So first, me as the guinea pig, redirected everything, right? Profile, including my documents, everything went to the file server. My home directory, my profile, my folder redirection, my app data, the whole shoot and match went off to the file server. And I ran a big, heavy workload. I did this for over 60 minutes, tracked all the counters, got all the metrics. As soon as I started the workload, I fired up my AC/DC playlist. And that playlist was located on the file server's home directory, right, on the network. I've got several hours of AC/DC music. I'm a huge fan. I even have them permanently inked on my arm. All right, so I'm definitely a big AC/DC fan. So I'm like, I'm going to listen to my playlist. I'm going to pull that out of my home directory the entire time I'm doing the test. So there goes, you know, well, that's going to generate a lot of IOPS, right? Guy's playing music out of his home directory. So that's the first thing I did. Then I ran Outlook, Exchange, Link. You know, I connect to our corporate Exchange server. We do Exchange over HTTPS. Don't need a VPN. You know, it's great. Same thing with Link. Just log in. I mean, I live and die by Outlook. I have a PST file and an OST file. I moved both of those over to my file server. So I'm running my OST and my PST from the file server. My mailbox on average averages anywhere from 3 to 4 gigabytes in size. I'm terrible with keeping up with email. I get way too much email. I can't keep up with it. I also create PSTs because anything I think is valuable, I save. So I put that in my PST. I'm always searching my PSTs, opening stuff from my PSTs, finding old PowerPoint presentations in my PSTs. So I did a bunch of work there. I mean, I'm opening documents. And I was like, you know what, let me bang on this a little harder than I normally do. Right? For this next 60 minutes, I actually want to work harder than I would as a typical user. So I'm ripping through these applications. I'm editing Word documents. I'm surfing with Firefox and with Internet Explorer. I download a 100 megabyte file from ShareFile to my redirected home directory. So I'm theoretically, you know, being the power user on the file server. So what kind of numbers did we come up with? How many IOPS did I generate at that file server? I mean, you're probably thinking, shit, man, it's probably crushed it, right? 5.7. Yep. Me as a power user, I generated 5.7 average IOPS over the course of that 60 minutes. Now, did I have spikes? Sure. There were times where the IOPS for like a second or two would spike a little higher. What kind of breakdown of IOPS did I have? 55% were read, 45% were write. Okay? That was the breakdown of me as a power user. Here are the overall numbers. My average read IOPS, 3.1. Write IOPS, 2.6. My peak read, 189. My peak write, 36. And there's the graph. So very spiky. But over the course of an hour of nonstop activity, no breaks, no phone calls, this is what it looked like. So for the majority of my actually active power user session, my IOPS were almost nothing. Right? File server wasn't even breaking a sweat, to say the least. And for the few times it spikes, the spikes don't last very long. Yeah, you write a 100 megabyte file to your home directory. That's going to generate a bit of a spike, right? Because you got to write all that data. The beautiful thing about doing large files like that is it is sequential I/O, right? So that's one of the benefits. Now, So, wow, that's not too bad. 5.7 IOPS, that's not much at all. What about a real world example? So I've got a customer. We've got about 30,000 active seats of VDI that are in this customer account right now, with everything configured the exact same way that I just laid out for best practices. One of the first units that we did, it was like a Zen Desktop 4 pilot. So this system had been around for a really long time, and it was like a little departmental pilot. So I decided to go monitor that. I'm like, let me log in here, because the customer was still using that Zen Desktop 5 departmental pilot environment. They never actually transitioned off to the newer system yet. So I went, I'm like, let me collect data on these real users. Do the perf moms, monitor the SAN activity, monitored the whole thing, looked at the users, and how many users were there? So first, this departmental pod, it only had about 440 users was the peak. Okay? And I actually monitored more than one day. I did it for several days over several weeks because I didn't want to just have it be an anomaly, right? So I monitored many different days over many different weeks. And 440 was the most they got to. And it typically every day, it was somewhere between 428, 429 to 444. So it was pretty consistent usage, mid 400s. Almost all the users log on between 7 and 9. A vast majority of them are logging in between 7 and 9 a.m. At one point during that login process, we actually get to a point where users are coming in about 1 every 30 seconds, firing up a desktop, right? You know, users, that's when they roll in. By 4 o'clock, users are out. So what kind of load did that generate? Well, interestingly, the so-called logon storm was my time of least load on the file server. That was when my file server was doing the least amount of work, was during the logon process, right? So that dreaded logon storm, gone. No network, no file I/O. Why? Because the profile was super, super tiny, because we had redirected everything, we had excluded everything, and we only re-included just what we needed. And in fact, in this environment, we didn't even turn on profile streaming. And had I turned on profile streaming, the reason we didn't turn on profile streaming is because with all the inclusion and exclusion rules, my average profile size for this customer was 10 megabytes. And that included the things that can't be redirected. By doing targeted inclusions, exclusions, I got them down to about 10 megabyte average profile. I'm like, well, I'm not going to worry about streaming for that. Just let it download. So what kind of IOPS did they generate during the logon period? The file server, I divided it out per each of the users, right, during the different times and sliced it up. 0.5 IOPS per user. So each user was generating half of an IOP against the file server. And the read-write ratio, about 40-60 during that logon period of time. And the average bandwidth, 0.07 megabits per second. Okay? 0.07 megabits per second was the average bandwidth consumed against the file server during that logon window. It's almost negligible. So what happens during the peak usage, when the actual users are actually hitting inside their apps, and they're running their apps, and they're running their desktops, and they're doing what they're doing during the bulk of the day? So I narrowed in. I tried to find, like, you know, the peak time is 10:30 to 4. You narrow in there, you know, about 10:30 to 11:30, I get like a peak sustained usage, and then again at about like 1:30 to 3 are the peaks, because people go to lunch, a few people start to go home, people are rolling in. But I narrowed in on like the best peak time I could find during that window, and I think the best peak was I think it was like the 2 to 2:30 range was like when the system was getting hit the hardest. Average IOPS per user on the file server that were being consumed, 1.1 IOPS per user. The read-write ratio, once I hit my steady state, if you were at our IOPS presentation, the steady state IOPS, 17% read, 83% write. There's our 80-20. That's what was actually hitting against the file server as well. Average bandwidth per user, 0.02 megabits per second sustained per user. It scales really, really well, okay? No issues. So now I decided to do some more testing with, and this was lab style testing using automated, you know, kind of canned workflows. What happens with 3 different scenarios? And we'll go through the scenarios, but in each of the 3 scenarios, I was going to do 2 tests. Let me just set up a lab environment. We'll do some tracking. We'll test what happens with profile redirection, streaming, no streaming, folder redirection, no folder redirection, and let's see what happens. The first test was just a log on, log off. Let me log in, open a few apps, see how fast they launch, right? And after like 3 minutes, log out. So what is the log on, log off load that generates? Now that's not a realistic workload because most users don't log in and log out in 3 minutes, but that tells me the amount of I/O that log on, log offs are generating based on the various profile strategies I picked. So it does give me valuable data. Then I decided, well, then let's do a test of at least a 20-minute workflow. I'll log on, open some apps, work some data, work on some email, basically generate some basic load, and then log off. And let's see what happens over 20 minutes, which gives us the more realistic, what's the holistic usage look like. In all scenarios, because most of us agree, documents, downloads, desktop should be redirected, in all the scenarios that I tested and all the data that we have, we did redirect those folders. So that was a non-negotiable. We redirect those big data folders. It was just the other folders that were redirected or not. So I had 2 different test scenarios within each. One was with a user that had a 125 megabyte profile with 100 of it inside app data, right? Your classic, very small task-focused worker. And then I went a little bit bigger and said, well, the 100 megabyte user's the exception, right? Usually, sometimes those things grow bigger than that over time. Then I said, what happens with a 225 megabyte profile? Again, with 200 of those megabytes coming from app data roaming. Okay. So track the logon times, application launch times. Track the file server IOPS, track the network IOPS. So here's the results. Oh wait, yeah, the last bullet. This is so critically important. I also tracked the IOPS and network usage to the VDI LUN. Because don't forget, it's not just the file server we're worried about, whether we're offloading or not offloading to the file server. There's also, based on what we picked, we're copying things to the VDI LUN, which could be on the same SAN with the profiles. So there's IOPS, extra IOPS that are being generated on behalf of that profile that's being cached on the C drive. So we have to track that as well, and I tracked it. So scenario 1, basic UPM with only redirecting the data folders. This is a standard roaming profile at this point. Because if you just install UPM and you turn off all the inclusion, exclusion rules and just do a few folder redirection for like my docs, all you've done is give yourself a roaming profile. It's going to work just like a plain vanilla roaming profile. Scenario number 2 was UPM with profile streaming and active write back turned on. That meant that the app data was going to stay in the profile, but use our streaming technology to minimize the impact and only bring down the things that actually have to get touched and put that on a C drive. And then the final scenario was UPM with everything, right? Let's do all the best practices and redirect app data. So here was the logon test. UPM with all the best practices, my logon time is 17 seconds. And again, that's a 125 meg profile with 100 megs of app data. My file server IOPS during that logon period for that one user hit 2. And my IOPS generated to the VDI LUN hit 32. Now the IOPS to the VDI LUN is more than just the profile coming down. It's any write going to the C drive, right? So anything that's being written to the C drive is going to the VDI LUN. 32 IOPS. How much data went between the file server and the VM? 8 megabytes of data traversed to the network. UPM with profile streaming. My logon went up a little, went up to 21 seconds. File server IOPS were heavier, 6 IOPS. The VDI VM LUN IOPS during that log on, log off also were at 45 as an average. So that went up. So we got the file server IOPS going up. We got the VDI VM IOPS going up when we turn on profile streaming without redirecting app data. File server still transferred 20 megabytes worth of data that came down. So, and a greater load on the file server. UPM with no redirection, log on was 28 seconds. This is your standard roaming profile, right? Log on was 28 seconds, file server IOPS were 18, VDI IOPS were 62, significantly higher, and we pulled 124 megs of data, which makes sense. It was a 125 meg profile, right? That's what actually went over the wire. So, we all agree, plain old regular roaming profile, not very good. So from then on out, I was like, I don't think we need to worry about testing that anymore. We all pretty much agree that's not a good way to do it. So let's narrow in on just redirection of everything and profile streaming without the redirection of those other folders. Now, when I looked at those two tests during the 20-minute log-on, now this is, let's forget about just the log-on, log-off, because we know that's an intensive process, right? So profile streaming definitely generated way more I/O, way more on both the file server and the VDI line. But what happens over the course of time as I'm running in a sustained environment? There's very interesting numbers. UPM with folder redirection, well, the log-on times are the same, right? That didn't change. The file server IOPS average sustained 1.5. Kind of in line with what my customer was seeing, right? About an IOP and a half per user while they're doing work. The VDI VMLUN IOPS 17, data over the network was 36. With profile streaming, I generated less IOPS on the file server, okay? That's a good thing. That actually is a good thing. Let's put a little tick there by profile streaming, good feature. But I also put, so for the IOP that I pulled from the file server, I threw 2 more at the VDI line, right? So the net gain with profile streaming was still an extra IOP. But over the course, pretty equal. I mean, you almost call that a wash, right? I'd call that about equal. The interesting thing, though, with profile streaming, instead of redirection, I pulled more data from the file server. So more data was coming from the file server, even though less IOPS are on the file server. And this gets back to our IOPS discussion by Nick yesterday in sequential versus random IOPS. Folder redirection of app data, every IOP going to the file server is random, right? It's app needs to read this file now. App needs to write that file now. It's all random. Profile streaming, uploading, and downloading, those are sequential reads. I need to read this 100 megabyte of profile data. File server, please read that for me. File server goes, well, that's a pretty nice big sequential read. So those IOPS are more efficient. Each I/O operation is pulling more data because it is sequential, right? So that's how your IOPS can increase, right? Or your IOPS might be a lower number, but your throughput is actually going up. So throughput was higher, IOPS were lower. So that's why you see that difference. So on the network, right, it was still a higher load that was being generated. But from an IOP chattiness perspective, it was fewer commands because we were able to be sequential in throwing it up, pulling it down. So what happens when we increase this, because 100 megabytes is small, to a 200 megabyte app data folder? Well, nothing changed with folder redirection. That was the beautiful thing. Because with folder redirection, I don't care how big it gets, I only touch it when I need it. And I don't download, upload it. I go out there, manipulate it where it's at, and come back. So no matter how big the user's profile grows, the usage would never change. They're only going to use what they actually touch. That was the beauty of folder redirection. What happens with profile streaming when I'm not doing folder redirection? And that profile starts growing over time, the numbers grew. My file server IOPS went up to 1.2 over time, right? My VMLUN IOPS went up a couple more as well because I ended up creating more stub files and working with a little bit more data. My network usage also went up. So as that grows, yes, profile streaming, fantastic feature. In fact, I would turn it on because you are going to have stuff that you include that just doesn't get redirected. So it helps. But as the profile grows, we're still putting more load with the profile streaming overall than we would if we just redirected it. So application launch delay and the myth and FUD around that. So people say, well, apps take longer to launch. Oh, maybe, but let's really analyze it. So I did about a bazillion tests, even in my customer environments and in my lab. Here's the results that I got. Outlook, no launch difference. Word, no launch difference. Excel, no launch difference. PowerPoint, all these things, no perceivable, detectable difference. Every time you run a test, you might get a few milliseconds here or there, a half second here or there, both with or without redirection. But when you mean it out and get the average, they're the same. Firefox, though, did launch slower. That one I actually got a consistent launch delay with app data redirection. And that's because Firefox has got a few bigger files that get kind of stored out there. And when you redirect app data, there was like a, for me, it was like a 15 meg file that had to go out and read as it was opening. And that slowed me down. How much did it slow me down? It was a 10% launch penalty. Yeah, 10%, okay, not insignificant. Let's translate that into real world scenario. It added 0.3 seconds to my opening of Firefox. Let's just say it added a second. Firefox is going to open 1 second slower. Oh, boo-hoo. Do you think the user wants Firefox to open 1 second slower, or they want their logon to be 30 seconds longer, right? Do you think your IT network infrastructure and your IOPS, your SAN administrators, want Firefox to open 10% slower, or do they want to triple their I/O load on the network and on the SAN, right? So let's buy more IOPS because we want Firefox to launch 1 second faster. Doesn't make sense.
Nothing, Shawn? Nothing?
I've got a lot to say, but we can wait through.
Okay, I think we got like a minute, couple
Yeah,
minutes.
I think we're getting low on time. We're almost done here. So, other test facts, with app data redirection, log on always faster. App data redirection, always a lower throughput load on the file server. Okay, app data redirection, definitely less IOPS on the VDI line. App data redirection, without question, the lowest load on the networking gear and infrastructure. So, to wrap this up, when dealing with non-persistent pooled desktops, when dealing with XenApp, you want to redirect all the folders Microsoft gives you, including app data, right? It's going to improve your speed, going to lighten your load on your infrastructure. You want to make sure that you follow the best practices for scaling it, right? So don't put everything on a single file server. Don't have a file server that's got just one RAID 5 array and 5 disks in it and be like, yeah, I'm going to put 10,000 users on that thing. Yes, you will get slowdowns in that aspect. You have to analyze how many IOPS do I need per user, what's my network throughput per user, and now let me, as I scale that up, what's going to work? How many file server nodes? How many NAS nodes? Do I need 10 gig? Can I get away with bonded 1 gig? So do your analysis first so that you don't create bottlenecks, but it absolutely scales very well.
I also want to say, so Microsoft changed their, on the first bullet, Microsoft changed their tune in like 2009 or 10. Their terminal server engineers, the guys that write the code, they actually came out and said that you should be redirecting all shell folders now. All machine-independent shell folders. So basically not app data local, but everything.
Right.
So end-user.dat's the only thing roaming in. That's their current best practice. I just don't think a lot of people know that. They didn't publish it that well. But.
So we got a lot of references in the article, and free to follow up on. You'll be able to download the presentation. But with that,
come on. You got to be chomping at the bit back there.
I definitely disagree with about 50% of what you guys covered. But I don't have the time to explain all the reasons why what you said I disagree with.
Okay.
I'll do a session next year, and I will refute the points that you've done with data to show my point of view.
go for it.
A couple of things I would like to suggest, that things you guys put in your deck that you probably don't want to convey to people. One of them is you talk about the size of the profiles being the relevance to the logon delays, these kinds of things. That simply isn't true. The size of the profile has almost nothing to do with the logon time. What slows down SMB file copies is the count of files. If you have thousands of 1K files, you'll have a super long logon time, but you can have a 400 meg profile that comes down in seconds because it's large files.
Yeah, you're right, because that would be a sequential I/O operation. So that is a good point. The number of files, not just the size, absolutely has an impact. Yep.
So that's one thing. Second thing is PSTs, folder redirection off of a Windows file share. Horrible practice. You get MFT locking when the thing expands, and you will have massive problems with IO locking on your file server.
So I'm going to have to disagree with that because I have thousands of seats with OSTs and PSTs. Okay. Office 2010 going to NetApp filers, right? Users putting all their data into PSTs, zero corruption.
Now this is BriForum.
Right. Right. Zero performance issues.
If you're doing NetApp, it's separate. If you're doing traditional Windows file share, Windows file servers, you have MFT locking.
So I'll be honest. I don't see in my enterprise customers, because I deal with the large accounts, very many Windows file servers. Most of my customers use NetApp. Some of them are using EMC as well. But NetApp is definitely the majority of the sys infrastructure that I see out there. And it works great. highly scalable.
Situations that you're getting as far as your timings for app launch delays, that's definitely not true. The impact of application data folder redirection impacts applications much more than
So I knew you would say that because we talked about that last year. So we did all this crazy testing, and I was like, we got to test that because I know Shawn's going to come back with that. We couldn't see it.
Couldn't get it.
I mean, we'll sit down and do the test together.
I'll show you the results.
Yeah.
We'll do this at BriForum next year. But the important thing to remember is that it's not only the application launch delay that causes you problems, it's the application's performance throughout the execution, not just the launch delay. So if you get that 10% launch delay, that also means practically 10% while the application's running.
No, that doesn't necessarily mean that. That doesn't.
Depending on if it goes back to app data all the time, sure, and it's a crappy app. Yep, we talked about that, but again, it kind of comes back to the pick your poison, right? It's like, do you want a long log on
So
time,
with a
or
non-persistent
maybe
desktop,
some
a
session
non-persistent
performance
pull
degradation?
desktop, you got to get the file somewhere, right? So are we saying that it's better to do that? Let's just go ahead and copy it from LUN1 to LUN2 and then back from LUN2 to LUN1 when the user's done.
Though, that you have that scenario. That excludes people that do physical desktop with folder redirection that have tiered storage.
What did I preface this session on? What does it apply to only? XenApp hosted and non-persistent pulled desktops. If you have physical desktop, Shawn, you're absolutely right. If I saw a customer redirect app data on a physical desktop, I'd box them about their ears. It's stupid. You don't do that. If you have a persistent desktop, you should never do that, right? But we're talking about XenApp and non-persistent pulled VDI. When the user logs on, there's no app data there. I got to get it somewhere. I either touched on the file server or I download it from the file server, copy it to the VDI LUN, write it there, and then copy it back up. That up and down is always going to be more of a penalty.
To your point, we can clarify some of these things. I think it's good.
Yeah. But persistent desktops, by all means, I would not redirect app data on a persistent desktop. Totally agree with you on that.
Next year. Let's do it in London.
Let's do it in London.
Yeah. Thank you.
Thank you.